Hi students, in this class you will learn the representation of three address code. Generally three address code that can be represented in quadruple or triple or indirect triple. So we can represent three different ways. So on to the first one, quadruple. So quadruple is a record structure with four fields. So generally these four fields are represented in the form of four fields we are going to be represent. So these four fields tells about the operators and whatever the operator that we are going to be using, and the second one is a argument 1 and the second one is an argument 2, and third one tells fourth one tells about that result. So first one is an operator, second one is an argument, third one is an argument 2, and the fourth one is a result. So this means that the intermediate code can be represented in the form of quadruples. So that means that, so for example, if you are going to be representing three address code in the form of A equal to B of C. Suppose if I am going to be saying that this is an expression. So here the operator is nothing but whatever the operator that we are performing. For example, simple example, some x is equal to y plus z. So here the operator is nothing but a plus. The first argument tables that contains a plus. That means that, so in the operator field you have to be define that plus, and argument 1 is nothing but a y, argument 2 is nothing but a z, and where we are going to be storing the result, so in the x field, so that is nothing but x. Like that we are going to be write on the three address code, three address code in the quadruple format. So we'll take with an example. So let us consider with an example of the expression I am going to be considering is A is equivalent to, so minus B star of C plus D. For example, this is an example I am going to present. So how we are writing a three address code for this one? Simply you are taking the temporary variable T1 is nothing but first you are evaluating that C plus D you are evaluating. After that temporary variable T2, so you are allocating that unary minus B you are going to be allocating. After that, so temporary variable T3 you are taking that T3 is having a temporary variable T2 that is multiplied with temporary variable T1. So and the result is going to be stored in the value that is nothing but T3. T3 is going to be allocating to the variable A. So this is a three address code. For this three address code, how we are going to be writing a quadruple format. For that I am going to represent in a table manner. So I am taking that four fields of notations. So these four fields tells about the first one tells about that address format, and second one is an, so tells about that addresses, whatever the addresses that we are using. Second one is nothing but operator I am using. Third one is nothing but argument 1, and fourth one is an argument 2, and the final one is a result field. So we are going to be written as the first instruction. What is this instruction three address code? That is nothing but T1 is nothing but C plus D. So here I am taking that in the address indexes I am taking it's 100. So what is the operator I am using? Plus is the operator. So in between of both of them, that is nothing but C and D. So we are applying the plus in between the argument 1 and argument 2. The result is going to be stored in the temporary variable T1. So in the next instruction, that is nothing but 101, I am going to be storing for unary operators, that is nothing but, suppose if your instruction is nothing but A is equivalent to op B. So if it is in this manner, the argument 2 for this type of instruction, that is to be nothing. So for that operators, for this operators you are going to be allocating that unary. So you are applying that unary minus. So you have to be write down that unary minus. So and then the variable is nothing but first argument is a B, second argument we don't have, simply represent a that is nothing, it is not a minus, it is nothing but we don't have any alphabets. That's representation we are going to be represent. So unary minus, and the result is stored in the temporary variable T2. So move on to the next location. So in the 1 or 2 location I am going to be allocating the multiplication between the first argument is a T2 and the second argument is a T1, and the result is stored in the T3 variable. And 1 or 3 instruction tells about that the value that is going to be allocated to the A, that is nothing, T3 is having the final result, that value is allocated to the A. So what is the operator that you are going to be allocating? That is nothing but assignment statement. So what is argument 1? T3. So what about the second argument? We don't have the assignment statement, we don't have any argument, so that's why I am going to simply hyphen I am going to be representing, and after that I am going to be store the result in the So in this manner we are going to be representing a quadruples. So move on to the next type of notations, that is nothing but triples. So when you are going to be talking about the triple representation, so generally a triple is a record structure with three fields. So the name itself tells about the three different types of fields. So these three different types of fields we can represent it as a like a operator, like an operator, and argument 1 and argument 2. So these are the three fields only we are going to be passing. So for example, if you are going to be constructing the triple notation for the same instruction, for example, this is a 3 address code, how we are going to be writing the 3 address code for this one. So first I am going to be writing a 3 address code. So first I am taking a copy of this one. So before going to that, I am going to be storing the addresses values also. Before that, I am going to be adding one more column that tells about that addresses. So in which addresses I am going to be stored. For example, I am going to be storing the instructions in the 500 location. So what is the first operation that I am going to be performing? That is nothing but a C plus D. So what is operator plus? In between both the operators operands between the C and D. The result is stored in the 500 location. So whenever it is necessary, you don't need to be allocate the temporary variables. Instead of temporary variables, you have to be call these addresses values only. So in the 500, for example, this is a 501 location, 5001 location. Sorry, 5001 location. I am going to be allocating a unary minus, so that is having the value of b, and where we are going to be storing the argument. Whatever the argument to, we don't have any arguments, that's why we are going to be representing a hyphen. So I'm coming to the next instruction location, that is nothing but 5002 location. In the 5002 location, we are going to be allocating the t2 multiplication between t2 and t1. So that is nothing but multiplication between t1. Where is t2 is available? T2 is available in 501 location. So that location value had to be passed here. So within the parenthesis, if we are represented that is having the addresses values of that 5000 and 5001. So that is nothing but this is internally it is having the value of t1. So actually you don't need to be write down. So this t1 and then t2, for easy understanding I am representing this is the value of t2 and this is the value of t1. So instead of calling this temporary variables, I am going to be call with an index position. That index positions I am going to be passing here 5000 and 5001. So where we are going to be storing the result. So now the next location is nothing but 5003. So in 5003 I am going to be storing the location. What is the operator that I am going to be using? Assignment state operation. So where the value is going to be allocating. So we are going to be store the value of a, and where is the available location that we have. So that is nothing but that is argument 1. 2 is nothing but 5002 location, whatever the value that we have, that is allocated to the a value. So like that we are going to be written the triples. So this is the way of constructing a triples representation. So next format is nothing but indirect triples. So indirect triples, in this form, the implementation of 3 address code, we consider a list of pointers to triples rather than the triples themselves. Instead of calling the triples themselves, we are going to be call these. For example, when you are going to be trying to be write down the indirect triple for this example, so we can use the array of statements to denote the pointers to triples. Following is the generally when you are going to be talk about that indirect triple. So I am going to be representing the following tells about the triple representation, indirect triple representation. So simply we are going to be take that only one field of the values. So otherwise you have to be take the two fields of the values. I am taking a left column. So I am going to be, for easy understanding, I am going to be maintaining here. So I am going to be talk about that indirect triple. So here we are going to be talk about the statements. So that is nothing but addresses. So in this way of, for the same example, if you are going to be talk, this is a triple format. Now we are going to be talk about the indirect triple. Instead of calling a triple, we are going to be directly calling the indirect triple. For example, I am going to be calling this instruction is a 100th location. So for example, in the 100th location, in the 10th location, I am going to be calling the instruction of 5000. So directly we are going to be pointer to the triple. So nothing to be whatever the triple notations that we have, the same notations you have to be passed as a reference to the next variable. So that is nothing but this is a next instruction is nothing but 5001. This next instruction is nothing but whatever the memory location subsequent that we have 5002, and next instruction that I'm going to be calling as a 5003. So like that we are going to be calling a indirect triples. Simply we have to be pass an addresses of the triple addresses. Suppose if you are going to be talk about that ternary operations like an array of, so an array that is nothing but a of, for example, array index positions, I am going to be representing a of I is equivalent to b. So in such case, how we are going to be writing the 3 address code? That is nothing but triple format. This 3 address code in the triple format. So when you are going to be writing the triple format for this one, so simply we have to be write down 3 addresses. That is nothing but, so one is an operator, second one is an argument 1, and second one is an argument 2. Third one is an argument 2. So when you are going to be talk about this type of arguments, you have to be represent this in the form of, first we have to be allocate in the operator field, you have to be allocate the array index positions followed by equal symbols, and the second position tells about the array name and then index position of that I value, and in the second position you are going to be allocating that value to a variable. For which variable you are going to be allocating? For b variable. So this instruction addresses I am going to be taking as, for example, this is the address field of that instruction. For example, this is a 100 and this is a 101. So now we are going to be passing that 100 instruction out of the data that we have, that is going to be passed to the b value. That means that, so the b is having the value to this array of ith position. So in the array of ith position, that is nothing but this is the address reference, this is the array name, this is the index position. For this entire index I am going to be allocating the value of b, whatever the b value that we have, that is going to be allocated to the array of particular offset address. So like that we are going to be writing a ternary operations. This is only for note purpose I am going to be telling. So suppose if you are going to be writing the any 3 address code representations array relation, so in such case this type of triple notation that can be very useful. So this is the way of writing a quadruple, triple, indirect triple. So once again I am repeating, quadruple contains 4 addresses fields: operator, argument 1, argument 2, result. So argument 1 tells about that first operand, argument 2 tells about the second operand, the result field tells about that whatever the value that is allocated, the result operand. So this is a simple example we are discussed writing a 3 address code for this example. So and this is the quadruple representation for the given example. If we move on to the second case, triple case. So when you are going to be triple addresses, that is only the name itself tells about the 3 addresses: operator, argument 1, argument 2. So this is the way of constructing a 3 address code for the given same 3 address code. So when you are going to talk about the indirect triple, in the indirect triple we are going to be pass the addresses of the triple addresses. So we don't call the indirect way. You have the name indirect tells about that whatever the addresses position that we have, that is indirectly calling to another address, that is nothing but indirect triple. Instead of rather we are going to be calling a triple, we are going to be called it as a indirect triple. So what is the address location? That is nothing but a triple. So this tells about the address of the triple notation. What is this one? This is a T1. Like that we are going to be writing the 3 address code for the 3 address code representation, either quadruple format, triple, or indirect triple format. So anyway, thanks for watching. So go with the different examples so you can get more clarity. Thank you.